Greetings and hello again. This is part 2 of the story about my recent journey with Claude Code. In this segment, I'll be sharing the slide deck illustrating that evolution of my use of Claude Code CLI from a little sandbox into a UAT swarm. Part 3 will follow this one. I'll be sharing the actual output, some of the project work from this swarm. And if you haven't seen part 1 yet, I do a very brief overview of some of the LLM interfaces that are popular on the internet right now, and a little bit of history about my own interactions with LLM. If you're curious, feel free to track that down too if you haven't seen it. With that, let's jump right on in to our sandbox to swarm. That title there is literally the arc. This started off as one Claude Code session in an isolated testing VM and evolved into a whole team of agent sessions driving real cross-distro test infrastructure. None of it was really a grand plan. Each step was just kind of the next move as I explored how to use Claude Code CLI. I was asking myself in the beginning, what makes Claude Code and tools like it different? And once I actually started using it and realized I needed to find its limits, what could it actually do, is what set me on this path, right? And there's a word of caution to go with this, right? The CLI experience showed me exactly how some poor people out there are making headlines when their AI agent goes rogue and makes a mistake that impacts the business. I did not understand how that could happen with a chat interface. I did not understand how that could happen with the IDE interface. With this CLI interface, it became clear within 5 minutes how that could happen. So my first order of business, once I understood exactly what Claude Code CLI was capable of, was getting it directly away from my SSH agent. I moved it off my daily driver just to remove that concern and made sure to put it in a place that had no credentials at all. I moved it to an isolated VM that already existed in my lab, just a standard Fedora 44 VM. It had Podman and Docker installed on it because I'd been using it for testing different things already. I didn't do any special prep. I just created a Claude user and dropped the install on there. Started working again, now feeling a little safer away from my daily driver credentials, right? I did go ahead and issue like a fine-grained GitHub access token specifically for the repo we were working in and gave it only the access it needed, right? So that we could work with the repo using the GitHub MCP, and it worked really well. So in the process of work, on a whim, I told Claude to go ahead and run some of the testing that I had been running, and it did. I didn't have to explain Podman. I just had to explain what I wanted it to do with Podman. Stand this up, install this, run this thing, and tell me how it shakes out. I think I might have actually used that terminology, tell me how it shakes out, rather than report back. And it did. The ease with which it kicked that off immediately had me ask, what else can I do? Like, if it can drive Podman and Docker like that, I've got to give it something else. And that evolution is what we're about to dive into and explore. A lot of what you'll see in use here is plumbing you may already be familiar with. I just gave Claude a way to use the tool. So we've already talked about how I fell into Claude. I already mentioned that I had moved Claude Code CLI onto its own box with some real tools, right? And you'll notice that I kept moving it to the right, pushing it farther from my personal credentials in any VM that I would actually care anything about, right? I figured if Claude is going to make a mistake, it's going to do it way over there. Yeah, I don't want it to make a mistake on my daily driver, and I don't want it to make a mistake on one of the first line machines in my lab. So shuffle it along we did. That way it can make a mistake over there safe with safe credentials. And we can zoom in on that a little bit. I do mention here that I taught it in about 15 minutes. And by that, I mean, once I realized that it could totally drive Podman, like there wasn't even a question about that. It was refining it. I used that as an opportunity to explore skill building in Claude CLI. So I went to the Podman docs and a few other things and our bash shell history and cobbled together a Podman UAT testing for this project, skill. And that did make the testing a little smoother. And it let me automate it. It knew then that when dev finished, it was time to test. And when if there was a bug detected, it would fix it before telling me I'm ready for your review. So it really was a lucky thing, I think, that I just chose one of the machines that had Podman and Docker there. I moved it before I noticed that that was there, and then I was like, oh, cool, now I'm right next to it and I can run UAT right here. It'll be easier for me to do it. And then whenever I actually got to that point and was about to, move over to the shell, I thought, yo, Claude. And sure enough, right? So, let's see here. No grand setup, just a polite request. It started taking off about then because we did get so much automation, and I could, run dev in one side, and as soon as it would finish, we'd kick off the testing in the other. Claude would spin up whatever containers it needed, do the testing, the deployment then the testing, and then tear it all down, right? Just no waiting. All I had to do was make sure that the work hopper stayed full. And it wasn't too difficult in serial mode like this because you're iterating and coming up with new ideas on the fly and working in that single session. That got me to thinking, I have this new testing engine here. How do I produce more input to keep it testing more, right? And how do I keep from getting in its way? So I decided to really let it run. I attached it to an entire fleet of virtual machines. All of these, I went snapshotted first, got them all ready to go, and then I gave Claude Code CLI root access via sudo. The design choice of them being disposable, the agent has root on each one, can be as destructive as it needs to be while we explore. And every box can just be reverted like that. So there's a pure safety net for exploration and just to really get crazy with what we can see Claude can do. And then I started solving that serial problem, and we scaled out to multi-sessions, right? I pivoted to another project that was created like from the ground up specifically to test this multi-session idea. And in that project, we have compute, storage, and network domains. I created a new repo. I dropped a very bare README and a project file. I opened Claude in that project, and I did a /init to initialize to the project and get it started. Once that one got started, I turned it into the UAT lead. Then I started 3 other agents in other shells. 1 for compute, 1 for storage, and 1 for network. And then I had a conundrum. How do I get these segments to communicate, right? I had no idea where to start, and so I just tried something. And I used the GitHub issue tracker because that's what we use, right? I know it's not optimized for agentic use, but it got the job done. Since we were connected with the GitHub MCP, The issue tracker ended up becoming not only the work queue, but also shared memory between compute, storage, and network agents to be able to exchange um, requests, bug reports, um, really anything to facilitate a final release. I did end up bringing this down to a single dev lead that is allowed to operate within each of these domains, and then a separate UAT lead. So I run two teams now rather than four, but it does work out a little bit better for me that way. It was really neat though, because compute would finish and close an issue, which would unblock storage, and storage would pick up its issue and turn around and read the notes that were left there by compute and use that when solving its issue before handing off to network. All the agents were commenting back and forth, referencing each other's issues, and the best part became this just visibility into what was going on. I could watch the whole collaboration unfold in the issue timeline, right? It was like reading a transcript of what the agents were thinking. And now for the orchestration itself. At first, the sessions were just using SSH, like I mentioned. Could SSH directly to the testing target and do the work. Then I went ahead and gave Claude SSH access to my salt controller. I did choose Publisher ACL and its own account and everything to try and make it a little safer, but I really wanted to see if it could do the multi-target orchestration through Salt rather than having to hit each test box individually. That worked really, really well. It was still a little bit not as efficient as I wanted. So as I was working and moving some other things around, it clicked that I don't have to stand up a separate salt controller for this. I'll just install the salt controller right there on the Claude Code VM, and we'll attach the minions to it. And that worked brilliantly. From that moment, the team lead could pretty much run salt commands directly against the test fleet anytime it needed. No SSH wait, no SSH lag, and as a side product, some of the sub-agents, and when I'm using agent teams, those team members can also access Salt to handle things themselves without having to wait for the lead. So win-win on that, right? It became really neat that with the control plane and the agent on the same box, that the whole fleet convergence just converges from right there. So we put all of that together and we get an automated UAT loop. And an important thing to state about this is it's not being run by a CI server. It's a Claude Code CLI session itself. That automation means that it, the session can write code, it can talk to SonarQube, it can interact with GitHub, it can do the salt stuff, it can do all of it. And there's no human needed to be involved unless it's just kind of bumping things along a little bit or maybe providing access or guidance for a particular architectural question. One of the big things that I found was a major benefit to that, though it is a little more costly than a CI server, right? Because you've got your Claude usage to worry about, is when Claude finds a bug, we can triage it right there. Grab the logs, grab anything. You can just start working the bug right there. Distract the UAT session with an entire development spike. But it's a lot more efficient, I feel like, to have it dive in right then when it happens, rather than trying to recreate the same scenario again later. Though with this setup and the snapshots being involved, we'll talk about it later, that most things are very, very repeatable, because once it goes off track, you can reset and run the test from the beginning. Moving on a little bit here. And this is the whole thing on one slide. 2 MCP servers at the top, GitHub for the project work, right? Sonar Cube keeps our code quality high, watches for security issues, keeps our duplication to a minimum, and I even try to keep code complexity or cognitive complexity down to a minimum. Um, I do make allowances in cognitive complexity, like in tests and things, but we do the work, since Claude's doing the work, to try and abstract everything to keep cognitive complexity to a manageable level, so that if I do have to get in here and actually start working with this code myself as a human being with my hands on it again, I'm not completely lost. That's the hope anyway. So you've got the dev and the UAT sessions running with subagents, the SALT infrastructure control plane right there, and then the version pinned fleet along the bottom. Every arrow here is pretty much something that an engineer or a CI server already runs. I just handed the agents the keys and the tooling, and in some cases a little bit of guidance, and let it run. So what does that buy us? What's the point? 6 OS targets exercised from a single issue, dev and UAT running in parallel instead of taking turns, and because of snapshots plus salt, every run is reproducible. You break the box, revert it, reapply it, identical every time. There are, your flaky tests. Those do happen, but this can debug a flaky test very efficiently. And not only that, it can help you run, a workaround around it, because it can get to like the actual core of the flake. And then the loop just keeps turning, right? So this was my sandbox to swarm journey. And that's where I'm going to wrap it up for part 2. I do hope you've enjoyed some of the information and the presentation itself. There's so much you can do with this tooling, whether it's Claude Code CLI, Hermes, Aid. I'm trying to think of a bunch of them. Not many others are coming to mind right now, but plug them into open source models, plug them into your subscriptions, and explore safely to see what you can do. And then join me again soon for part 3, where I'm going to explore one of the larger projects that I'm actually working on in the setup. I'll show some of the code. I'll show the GitHub issues and some of the generated documentation, and of course the application itself. Until then, have a good one.